Y'all, something that's always interested me in math, y'all, is that how we can manipulate like base 10 numbers. We can also manipulate certain types of numbers. Like, I don't know exactly how it works, but if you put a certain amount of zeros after subtracting a given number, using that product and putting it in front or in back of the number, for example, with certain zeros behind it, it would still be divisible by our original number. So, I know that, like, y'all, I'm just saying a bunch of garbled words right now. So, let's show an example. So, we'll begin with this a little bit slowly because my editing needs a little bit of time, let's be honest. So, we have the number 1001. Let's go ahead and subtract this by 6. We have the number now 995. But let's use that number 6 that we subtracted from and instead put it in front of the number 995. Alright? So now we have 6,995. Now this time let's put 3 zeros behind it. So we have 6,000,995, or should I say 6,995. And because it has that right amount of zeros behind it, divide that by 1001 and you get 5,995. The reason that I say this, y'all, is that this is very interesting of math because 6 plus 995 equals 1001. So you're still going to get the same answer no matter how many numbers you subtract from 1001. So definitely something interesting. Let's go to another example now. We have yet the same number, positive 1001. Let's go ahead and subtract it. 15. So we have the number 988 now. Alright, it's a cool number, alright, 988. But this time, we put that number 13 in front of 998 with a certain amount of zeros. Now we have the number 13,000,988. So divide that by 1,001 and then you'll get 12,988 as a remainder. Alright, so those are some interesting examples. So let's say now, y'all, we have our original number, positive 91. Subtract this time 6 in front of the number, like not how you usually subtract, but subtract 9 by 6, so we have the number 31. But this time, we put that 6 in front, well, in the back of 31, so that with a certain amount of zeros, we're going to get the number 31,000,006. If you divide this number by 91, you'll get 34,066. The reason that this works is that this is very similar to modulo math. This is a very core base of number theory, and no matter how much you subtract or add, it's still going to equal the same number, right? So let's try out a more smarter one. So we have 1001 minus 30. All right, so very simple, y'all. We have the number 971. Now, let's put that 30 in front of 971 now that with a certain amount of zeros, you have the number 300,00971. When you divide that by 1001, you'll get the number 29,971. And I know one question is out there you guys might be asking me is that what is the role of these products and what's the role of the numbers that we get after dividing it? For me, I haven't found out that exactly, but it's just how division works. Alright, these are just random numbers, but they're still connected. So that is connected to number 3. So let's say, for example, 31 plus 60 equals 91. 988 plus 13 is 1001. 6 plus 995 is 1001. And with a certain amount of zeros, divisibility still remains. No matter what the number is, even if I have like 2,000,999, it is still divisible by 1001 because when you still add them up, it still results in the very much the same numbers. I find it interesting, y'all, is that I like to think it in that some people think I'm addicted to using my calculator. Like, sometimes I think I am the only boy in any friend group to actually have an addiction to using calculators, like not the direct to crippling, always chasing divisibility, even at its roots, even at to extend division to its maximum point. And I know a lot of you guys have questions right now, so let's connect this to a simpler metaphor. Let's say we have the quadratic form y equals x squared plus 2x plus 1. Let's move negative 1 to the side, alright, into the side of y. So we have negative 1 equals x squared plus 2x. It's still the same thing, is that once you put this negative 1 back into the same form, it's still like the same calculation. It's still the same roots, same parabola. If we convert this into vertex form, y equals x plus 1 squared, it still functions as the same exact parabola with the same roots. It only has like one root, I believe that was like 2, 0. And the same thing is, when you factor it or add it back into its normal form, they remain the same. They remain the same function that is still calculated. This also goes similarly to modulo and arithmetic number theory, is that 1001 minus 6 equals 995. So any combination with 6 and 995 for this example will still equal to 1001. Even if you put it in the back of 995, you have 995, any amount of zeros, and then 6, it's still going to end up being divisible. So that's definitely, I find that really interesting. Is that math can go a lot of places, all right? School teaches me, obviously, parabolas. It teaches all of us parabolas, quadratics, equations, a ton of this stuff, even once I moved down to, like, IM3 or integrated math 3. But I definitely find these types of things interesting because it's this type of thing for me, because I want to know. Math is interesting sometimes.